Welcome to Summarize Science, where we dive into the latest breakthroughs in space and physics. Today, we are looking at a massive new study that used the James Webb Space Telescope to find more than 100 magnified stellar events in a distant galaxy. These researchers focused on a target known as the Dragon, a galaxy located billions of light-years away that appears stretched out into a long arc. This stretching happens because of gravitational lensing, where a massive cluster of galaxies in the foreground acts like a giant magnifying glass. Normally, it is impossible to see individual stars at such huge distances, but the researchers took advantage of a phenomenon called caustic crossing. Imagine the dancing patterns of light at the bottom of a swimming pool. Those bright lines are caustics where light is extremely concentrated. When a star in the distant galaxy passes through one of these cosmic caustics, its brightness is boosted by thousands or even millions of times. Before this study, the record for detections in a single-lensed galaxy was only 44, but the researchers have now pushed that number past 100. By using James Webb's powerful infrared cameras over 3 years, they were able to spot these stars appearing and disappearing as transients. The researchers used 2 different software algorithms, DFIND and S-Extractor, to identify these tiny flickers of light amidst the noise. These detections are not just cool to look at, they provide a brand new way to study the very first populations of stars in the universe. The researchers found that the spatial distribution of these stars helps them understand how many bright stars exist in these early galaxies. They also used these events to test our theories about dark matter, the invisible stuff that makes up most of the mass in the universe. Specifically, they looked for something called parity asymmetry, which is a lopsidedness in where these magnified events occur. This imbalance is a potential clue for wave dark matter, a theory suggesting dark matter behaves more like a wave than a particle. Beyond dark matter, these 100-plus events help the researchers create more accurate maps of the gravitational lenses themselves. By seeing exactly where the stars flare up, they can trace the critical curves of the lens with much higher precision than ever before. Each detected event was cataloged with its exact coordinates and the specific time it was observed by the telescope. To recap the most important points, the researchers have more than doubled the number of known magnified star events in this specific region of space. This massive jump in data means they are no longer just looking at lucky coincidences, but are starting a real statistical study of distant stars. In the future, this technique will allow scientists to see the most massive stars that lived shortly after the dawn of time. It also provides a unique laboratory to finally pin down the true nature of dark matter by observing how it warps the path of starlight. This work highlights how James Webb is acting as a precision tool for fundamental physics. Stay tuned to Summarize Science for more updates on how researchers are peeling back the layers of the cosmos.